Morning, engineers, and welcome back to today's episode. So last week we focused a little bit more on optimization, and today we will focus on different solver technologies. So far we used in our workflow the 𝐤𝐸 integrated preprocessor plus the 𝐤𝐸 integrated solver. And today we will give the consumer the opportunity to choose between different technologies. In our case, we will give the opportunity to run, instead of with the 𝐤𝐸 solutions, the workflow with 𝐤𝐸 solutions. But for sure, you could also extend this to mesh free solutions as from Intect solutions, or to solve it with Nestra, Abacus, ANSYS, whatever. Same works for the pre-processing with meshing with ANSYS or meshing with ANSYS. Okay, so to do this, we slightly need to modify our workflow, and you can already see the screen. And what we have to do, first thing, to provide two different streams to do the meshing. And for that, first we need to have this HyperMesh shell mesh node, and you can already see, okay, there's also this ANSYS node, and let me search for it. There should be also the ANSYS node. Here we go, ANSYS prime shell mesh. Okay, but as said, we want to use the 𝐤𝐸 solution, and now we already have the body, so we just put drag and drop the cable into here, but that's not what we want to have. We want to decide, okay, either the flow is going through the upper nodes or through the lower nodes. And you already learned this function of this stream gate. We had it for the mid-surface TCL script, and we will use the same one for here. Okay, stream gate. So the input we add here, and saying, okay, this is output 1, output 0. And as the gate, we add here this drop-down menu saying for value 0, it's 𝐤𝐸. For value 1, it's 𝐤𝐸. Okay, and let me check. So if this is 𝐤𝐸, we have an output here, and we have a null value here. Okay, the element size we already have defined. And now we just have to merge these two. The outputs, so we have here these two shell meshes, and then we get two outputs, but one is null, and there is a pretty good function. You can say clean, and then it removes all the null values, and now we have again just one value. Let me check if we switch it, if it works. So this takes some seconds. Till we are waiting, we can already connect to this. And then, yeah, let's check later. Okay, now it worked. So we have again 1. Here the input is working, here is a null value. Okay. So the preprocessor is already changed, and now we do the same for the solver. We just add OptiStruct. We use here a stream filter again, a stream gate, sorry. Move it a little bit to the right. I have here the stream, the outputs, and here we just add one argument to make it a little bit more stable. And the gate we don't have to create again because we already have it. Just connect it to here. And as this is one of the long wires which could annoy, and I think it's not super relevant to see it, we can also hide this to have a little bit better overview when we are working with our workflow. Okay, and at the end we have to do the same again, the merging. just merge the input here and here, and that's the output, and we have to clean it, and then we just hide all the things we don't need. In the meanwhile, some of the things appeared in viewer, but we can already see now. We run the simulation with OptiStruct. You see here the result, and if we switch now here to 𝐤𝐸RA, everything runs with 𝐤𝐸RA. For sure, we could now optimize a little bit the mesh settings and fine-tune this, but more or less the nodes working in exactly the same way. It doesn't matter if this is an internal node or if we remote control one of the external tools. Just some of the settings might be different because some tools might offer more options. Okay, that's it for today. So I can't wait for next week, because next week we will create a little material database. So it's a pretty easy one. We will just use Excel for it and connect this material database to our workflow to give the consumer of this workflow the option to choose between different materials. Okay, with that, stay tuned. Talk to you next week. Bye-bye.